All right, we're gonna look at the top of page 3 real quick, and then we'll kind of talk about a more like systematic approach. You can pause the video if you want, and get those directions up here. This is kind of my like shorthand version of what I'm about to tell you. When you are drawing these, so it's kind of helpful to have the Fisher projection in the center, show equilibrium, that equilibrium exists between the two different forms. And then again, if it is a alpha form, this OH on carbon 1 will be pointed down. If it is beta, the OH will be pointed up. The carbons 2, 3, and 4, that's your down, up, down. So if it's right, left, right, that's going to be down, up, down. So down, right, and left, up for those. So this is carbons 2, 3, and 4. And then depending on whether or not you are in a D or an L configuration based on the Fisher projection, D will be flag up, so there's that flag up, and then L will be flag down. Let's take a look here at a PowerPoint that kind of walks you through how to do that. Let's see. Boom. Drawing Haworth projection. So here's again D glucose, right, left, right, right. And then probably the first thing you want to do is draw your Fisher projection in the center. Draw your equilibrium arrows to either side, and then I would just draw like kind of template Pyrenees rings with the oxygen kind of at the like 1 o'clock or 2 o'clock position in the ring. Kind of, if we can agree on that convention, it's going to make everything a lot easier. Then, not a bad idea to number your carbons, and don't forget, carbon number 6 is up and out of the ring. It will be up and out of the ring. If it is in the D form, it will be down and out of the ring if it is the L form. This is D glucose. That means carbon number 5 right there. The hydroxyl on carbon number 5 right there is pointed to the right. So we are going to have flag up. And then carbons 2, 3, 4, we have right, left, right. So in carbons 2, 3, and 4, we're going to have down, up, down. So down, right, that's the easy way to remember that one. And then left is the opposite one. And then the last part is just assigning alpha or beta forms. So alpha, the OH will be pointed down, and beta, the OH will be pointed up. It's a little weird because like before when we drew zigzag structures, it kind of like if there was a line with nothing on it, that meant like a methyl group. And in this case, what we're talking about when we're drawing carbohydrates is that the line with nothing on it is a carbon to OH bond. So there's a hydroxyl, another hydroxyl, another hydroxyl, another hydroxyl, etc. So we have alpha D-glucopyranose, D-glucose, a straight chain form of Fisher projection, and then the Haworth projection of the beta D-glucopyranose. Fun times.